this, so we'll write and, vertically compressing it, let's do by a factor of 1/4. Ready? Original equation. To reflect something, you simply make it negative. So we have x plus 2, quantity cubed. Now to vertically compress it, we just have to multiply the whole thing by that 1/4. So I'm going to move this negative over a little bit, and we just put a 1/4 out front. That's it. Okay, now let's take a look and see if we can apply this just a little bit further. Problem 1. If we have y, whoops, there you go. If we have y equals x and y equals x minus 2, how are they related? How are their graphs related? Well, I hope you can see that there's just a minus 2 in the back. So I'm going to write minus 2 in the back. What does that mean? It goes down 2 units. So if one line looked like this, the other line would be down 2 units. It would just be down 2 units. Let's look at problem 1. Let's say we have x squared minus 1. This is a quadratic, and we want to move it up 5 units. So moving it up 5 units adds 5 to the back. So I'm going to add 5 to that negative 1. So it's y equals x squared plus 4. And I do have this quick little question. Do I change my x's if I had to graph it? No, because it's not moving left and right. Okay? Well, up and down you would never change your x's. The next one. Let's say we have 2x and 2x minus 3. Well, what's different? The minus 3 in the back. What does a minus 3 in the back mean? A minus 3 in the back means that it moves down 3 units. So if the first graph looked like this, the second graph would look like this. It would just be down 3 units. Okay, now we have this new equation. It says h of x is going to be the reflection, that means make it negative, of 3x plus 3 in the x-axis. What is the new function rule? So reflection in the x-axis means distribute in a negative. Okay? So we are just going to make that h of x equals negative 3x minus 3. So both values would change. Next page. Problem 4. This time they're not giving us an equation, they're just giving us a list of numbers. It's not necessarily a straight line, it might not be quadratic, it might not be any shape, it's just a whole bunch of points. So this is f of x. Now we have a new equation, g of x, and they want g of x to be 3 f of x's. I hope you know that when we multiply by 3, maybe we want to write that down over here. Say it's multiplied by 3. That's a vertical stretch I told you at the beginning of the lesson. So what's different? The 3 times, that's the different part, that we have 3 times f of x. What does that mean? It's a vertical stretch. So your x values stay the same. Go ahead and keep all these x values the same. It told us to vertically stretch it, which only changes the y's. So keep all those the same. Negative 5, negative 2, 0, 3, and 5. Don't change your x values. All of these just get a times 3, which means it's going to be really tall. So 2 times 3 is 6. 2 times 3 is 6. Negative 3 times 3 is negative 9. 1 times 3 is 3. And where are we at? Negative 2 times 3 is negative 6. So those are our new y values. Last thing we need to do is it asks us to graph both of those. So let's graph the original f of x. Negative 5, 2 goes 1, 2, 3, 4, 5, 1, 2. Negative 2, 2 goes 1, 2, 1, 2. Let's see, what's next? 0, negative 3 goes down here. I'm just plotting my original dots right now. 3, 1, 1, 2, 3, 1. 5, negative 2 would be right here. So go ahead and plot those if you haven't. Might pause the video if I'm going too fast. Connect them. It looks kind of like a weird check mark. Okay, this is the original. This is f of x right here. And then they want us to plot our new points so we can visually see what happens. So negative 5, 6 goes all the way up here. 1, 2, 3, 4, 5, 6. So see how much taller it is? It's because we vertically stretched it. Negative 2, 6, much taller. 0, negative 9, much taller. Whoa, way down there. 3, 3, again, much taller. 3 times as tall, hopefully. And negative 6 is going to be way down here. So look at the second graph. I'll put it in a marker so you can see how it's like vertically stretched, hopefully. It looks like somebody grabbed the top of it and the bottom and it just pulled. See how much taller and stretched out it is? That's what we call it, a vertical stretch. So this is the new equation, g of x, which was a vertical stretch of 3. So that's a visual on how a vertical stretch works. It looks 3 times as tall. Maybe we want to write that down. 3 times as tall. That's why we call it a vertical stretch. Okay. Let's say I have y equals x minus 3 squared, and I want to vertically compress it by 1/2. Well, that just means to multiply by 1/2. And it just means to throw it out in front of the parentheses. Y equals 1/2 x minus 3. Doesn't tell me to change anything else, but now it's twice. And if I show you on a calculator, let me show you what those two look like. So the original was x minus 3 squared, and the second one was 1/2 x minus 3 squared. When I show you what it looks like, it's going to do the first one, and now this one's going to look like somebody stepped on it. See, it's a lot shorter, it's a lot flatter. It's almost like they took this one and kind of whoosh, kind of stepped on it and flattened it out. All right, we're getting closer, I promise. Transformations from f of x to g of x. Can you see, firstly, can you see how the 2 becomes a 6? I hope you know that happens by multiplying by 3. The last thing, can you see how there was nothing and now we have a minus 1? In the back, I'll put that in the back because that kind of helps us visualize. The times 3 is a vertical stretch of 3, and the minus 1 in the back moves it down 1 unit. So you're comparing the 2 equations and seeing how they change. We're getting closer, I promise. We need 2 more questions. Okay, we have a graph. We have a g of x and an f of x. They're saying f of x equals x. Now here's what they want us to do. Let's write that down. Original is y equals x. I hope you guys remember f of x and y are the same thing. Okay, I can draw an arrow if that kind of confused you there. There you go. We're going to vertically stretch it, which means we're going to multiply it. So we're going to vertically stretch, which means we need to multiply something. And we're going to translate it down. So we're going to vertically stretch it by 2. And we're going to move it down 3 units. You ready? So to vertically stretch it, I have 2x. Just multiply it by 2. To move it down 3 units, just put a minus 3 in the back. And they wanted us to call that new equation, they wanted us to name it g of x. All right, we'll name it g of x. Hopefully that went all right for you. All right, let's try a couple more things. Ready? One more. So let's say we have an original function of y equals x squared. You ready? It's asking us what the heck happened to it. Well, let's talk about what the plus 4 did to it. So now we have this new equation. The plus 4 was inside, right? It was inside with x. Well, a plus 4 on the inside, oh, look at this convenient cheat sheet right here. A plus 4 on the inside means it moves to the left. All right, left 4 units. Oh, that was kind of lazy, huh? There, left 4 units. What do you guys think the minus 2 in the back does? I always find these ones the easiest ones to do. When you add a minus 2 in the back, that's just going to move it down 2 units. All right. I hope this lesson was helpful. I hope I did a better job than I have in the years past. I redid all the notes, all the homework. If you have questions, come in and ask. And maybe even want to jot some down. And you're like, well, what if it's this? What happens if this happens to an equation? I'll be happy to answer those questions in class, and then we'll work on your classwork tomorrow. Have a great day.